Okay, so we'll continue some part of lecture number 20 again. So we'll solve one more numerical on RC series circuit. So that is numerical number 5. It reads as follows: a resistance and a capacitance are in series, is connected across 250 volt supply. So this 250 volt is what? VRMS value. Draws a current of 5.8 amperes. Again, what is this current? IRMS value at a frequency of 60 hertz. So your frequency is also given. We need to find the value of capacitor and also the power drawn and the power factor. Given the value of R is 20 ohms. So basically, we have been given this situation that it's a series RC network, all right, and here the current I is flowing AC current I because of AC voltage over here, right? So how will you find the impedance first? First, we need to find impedance, right? So how do we find impedance? That's the thinking strategy. What we need to find? Capacitor. How will you find capacitor? If you know XC, can you find capacitor value? XC, right? XC is 1 upon 2 pi FC, right? From there, I mean, I am going from here. Okay. So first of all, how will you find Z? Is current given? Is voltage given? Yes. Correct? So how will you find Z? V by I. Alright. Then Z square is, in this circuit, Z square is R square plus XC square. R is known, Z is known. Can you find XC? And XC is what? What is XC given by? 1 upon 2 pi F into C. So if you know the value of XC, you can find the value of C easily. Alright. And once that is known, what is will be phi phase angle tan inverse of XC upon R. We have already done the analysis. Then the power factor will be cos phi and the power drawn will be VI cos phi. Alright. Okay, so let's start. Everyone. So please write down the solution along with me. Don't lag behind a lot. Okay, so let us begin with the solution. So what's the first thing you will find? Is V is given. Can you write V in the actual form, polar form? How will you write it? How will you write V in actual polar form? So V is actually I into Z, right? We need to find V. So V is what? VRMS is what? 250 volt. And what is I given as? 5.8 amperes. So here, what will be Z now? What will be Z? Z will be V by I. So calculate Z 250 upon 5.8. We are not writing in the polar form, we are just dividing VRMS by IRMS. We can do that also. So what is the value? 250 upon 5.8. I don't have the answers over here, so please help me out in this. 43 point. 43 point what? 1. Okay, so that's the value of Z. So once we know the value of Z, we know for a RC network, Z square is given by R square plus XC square. Now I need to find XC square, so that will be Z square minus R square. Z square is 43.103 square minus how much is R given as? 20 ohms. So minus 20 square. So tell me the value of XC square. Not XC, XC square. How much it is? Anyone with the value? I want XC square value. 1. Loudly please. 1457.86. So how much is XC? Square root of that. Please find out the answers. Let me know quickly. How much is XC? 38.18. Okay, that's the value of XC. So from here, can I find the value of capacitor C? Yes, I can. What is the formula? Xc is 1 upon 2 pi F into C. So what will be capacitance? 1 upon 2 pi F into Xc. So substitute the values. C is 1 upon 2 pi. What is frequency given as? 60 hertz, 60 into 60 into 38.18 ohms. So whatever value you get, always calculate in microfarad. Calculate the value of capacitor in microfarad. Convert into microfarad. Use your calculators. What's the value of C in microfarad? Sorry? Acha, you're still calculating. C value is? How much is the value C? 6.9? 6.95? Are you all getting this? Is it 6.95? Huh? 69.5 into 10 raised to minus 6 it is? So 69, no? You're getting 6.9 into 10 raised to minus 5. So it will be 69. 69 point? Huh? 0.4. Okay. So please complete it. 69.4 microfarad. Alright. Now how will you calculate phi? Phi was tan inverse of XC upon R. What is XC? 38.18. R was 20. So calculate tan inverse of 38.18 divided by 20. So this is the value of capacitor. So now we have to calculate the phase angle phi. How much is the value? 62 point degrees. Okay. Now what we will calculate next? We need to calculate power factor. So power factor will be cos phi. So calculate cos of 62.35. How much is the answer? 0.440. It is leading or lagging? It's leading, right? It's a capacitor. Leading, right? Are you getting these answers? 0.4640. If you are getting anything different, let me know. Then what's the last thing left? Power. What is power given by? VI cos phi. How much is V250? What was the current value? 5.8 into cos phi, which is 0.464. So calculate the true power now. That will be in watts. Anyone? 672, 672.8. What's the unit? Watts. Yeah. So this is the answer. In these type of numerical, the advantage is the total marks are not dependent upon the final answer. Intermediate also you can score marks. Are you getting it? If this numerical is asked in exam, actual power will be reserved 2 marks. Power factor will be 1 mark. Phase angle will be 2 marks. Then capacitor value will be 3 marks. XC value will be 1. To find the value of Z will be 2. That it comes out to 10 marks roughly. Okay. So whatever knowledge you have related to RC circuit, you should apply it. Now over here, the sequence is important. If the sequence doesn't click, you'll keep on revolving around it. And you keep on using the formulas which are forcefully not required. So please follow the thinking process which I've used over here for every numerical. First write down what you need to find out and what are parameters you all or whatever data you all have. Okay? Fine with this? So with this we complete series RC circuit concept analysis plus numerical. Concept in the sense voltage triangle, power triangle, impedance triangle, phasor diagram with I as a reference, V as a reference, and we have solved 4 or 5 numericals. Okay, now write down the main heading. This is the last part of 2.3 module, which is for your upcoming exams. RLC series circuit. Please, whatever I make you write over here, only write the equations, okay, and the diagrams. That's it. No need to write the theory. Theory you can refer it from the handout. So write down the heading RLC series circuit. So RLC series means R will be in series with L. Inductor will be in series with capacitor. So over here we apply the voltage V of frequency Hertz. Okay, and the circuit current will be capital I. Individually across the resistor, voltage will be VR. Across the inductor it will be VL, and across the capacitor it will be VC. If I combine R, L and C, resistance, inductive reactance and capacitive reactance, total is Z. So what is my V given by? I into Z. That is clear. So this thing is very, very clear. Total voltage is total circuit current into total impedance of the circuit. Okay. Now, V is the RMS value of the applied voltage, I is the RMS value of the circuit current, Z is the impedance of the circuit. Now tell me what is VR from here? If you have really understood the concept, you can tell me this answer. What is VR for this circuit? VR, current into resistance. What is VL? Current into inductive reactance. And what is VC? Current into capacitive reactance. Okay, so this is what you get, right? Because current in a series circuit remains the same. Okay, in short, what do you mean by inductive reactance? Inductive reactance similar to uska resistance. Opposition to the flow of current in a capacitor is called as capacitive reactance. Opposition to the flow of current in an inductor is called as inductive reactance, XL and XC. Okay, so write this down. VR is I into R, VL is I into XL, VC is I into XC, and V total voltage is I into Z, where Z is the total impedance of the circuit. Okay, now the tricky part over here is VR is in phase with current, correct? In case of an inductor, current lags behind the voltage. That means voltage is leading the current, right? So in case of an inductor, VL is leading the current by 90 degree, and in case of a capacitor, current is leading the voltage. That means voltage is lagging behind the current by 90 degree. Okay, so please note it down. Yeah, completed. So that means, how will you know whether the RLC series circuit can be effectively inductive or capacitive? How will you know? What value it depends upon? It depends upon whether XC is greater than XL or XL is greater than XC. Then the circuit becomes inductive or capacitive. It cannot be both at the same time. It will be dominantly one, either capacitive or inductive, depending upon the value of XL and XC. Right. That's what I've written over here. So for the first case, write down the first case. We'll consider inductive reactance is greater than capacitive reactance. That means XL is greater than XC. Okay. So just wait now. So if XL is greater than XC, can I say VL is greater than VC? Because VC is I into XC, VL is I into XL. Okay, VL is greater than VC means what? The circuit behaves like a RL series network. Okay, so how will you draw the phasor diagram for XL greater than XC? Now tell me. I've already drawn the phasor diagram below, but I want you all to try. How will you draw? Taking current as a reference point. I want to draw it over here. Taking current as a reference. So this is current as a reference I. Now how will you draw? Tell me, you should be able to draw this. Now I will draw voltage VL. Voltage VL is leading the current by 90 degree, right? So where will it come? Over here. This is VL. Okay. Where is VR? Over here. This is VR equal to I into R. And where will be V? Where will be VC? Sorry, VC. VC किधर होगा? VC will be down. So I have drawn it over here like this. Okay. And where will be V? This is V. And this will be phi. Okay. And what will be this point? This height will be what? What will be this height? This blue color line is VC. So what will be this height? VL minus VC. Got it? So the bigger diagram of this is over here. So please draw it, taking current as a reference point. Did you got it? VR is in phase with the current. VL is lagging. VC is lagging behind. VL is leading the current by 90. VC is lagging the current by 90 degree. Instead of showing it down, I have showed it up only, but with an arrow down. Why is VL bigger than VC? I think that is the case we have considered, right? So please draw it. So whatever the difference between VL and VC is, that much will be coming over here. Here. VL minus VC. So where VL minus VC will be I into XL minus X. So please draw this phasor diagram. So first you draw I, then you draw VR. VR I have not shown the arrow. Then you draw VL. Opposite you draw VC. And then where will you mark V? How much you will mark V? Whatever the difference between VL and VC is, that much will come over here. Okay, so please draw the phasor diagram. This is for the case XL is greater than XC. Okay, remember it. The circuit is inductive. This is the phasor diagram with arrows. From this, your voltage angle will come. Please complete it fast. What is phi called as? Phase angle. And we have taken the reference as current. Please draw this. In the exam, it can come. Explain RLC series circuit. Draw its phasor diagram, voltage triangle, power triangle. It can come in exam as a theory question. Why not? Or numerical can also come. So drawing phasor diagram is as important as solving a numerical. Understood every aspect of it? Now we just extend this. Completed? Okay, I'll keep both together. Now from here only your voltage triangle comes. V is I into Z, VR is I into R, and this is VL minus VC, which is I into XL minus XC. So this becomes voltage triangle. Same thing. I've taken it of it and drawn it over there. So please draw the voltage triangle also. This is phasor diagram. And this is voltage triangle. Remember, this is only for XL greater than XC. We have to consider the case for XC greater than XL also. Following? Why this is VL minus VC? This I into XL minus XC. Achha, what will be tan phi? Tan phi opposite upon adjacent, right? So here it is. Tan phi will be VL minus VC upon VR. That is just geometry. So from the diagram, what can you say about the current and the voltage relationship? From this phasor diagram, what is the relationship between the current and the voltage? Can you tell me? Current I is lagging behind the applied voltage. Voltage is first, no? So current I is lagging behind the applied voltage by an angle phi, where phi is less than 90. So what is the nature of the circuit? Inductive. Wherever the current lags behind the voltage is inductive. Have you drawn the voltage triangle also? Yes. And what is tan phi? VL minus VC upon VR. Just from the geometry from the circuit. Okay. So that's what we have said. Clear from the phasor diagram that current I lags behind the applied voltage by phi. So nature of the circuit is inductive. Now write down the phase angle of the circuit. Phi will be tan inverse of VL minus VC upon VR. What is VL minus VC? VL is I into XL, VC is I into XC. So I've just done that to cancel out I and I. And finally, my phase angle will be tan inverse of XL minus XC upon R. So please note down this formula. This will help you to solve a numerical. Okay? What will be power factor in this diagram? What is cos phi from this angle? VR upon V, correct? So what is the power factor? Power factor will be VR upon V, which is nothing but R by Z, and that will be lagging. Why lagging? Because the nature of the circuit is inductive. So please note it down. Power factor will be cos phi, and cos phi from the voltage triangle is R by Z, VR by V. Now from this voltage triangle, how do you get impedance triangle? Divide every quantity by I. In the voltage triangle, divide everything by I. So let me show you voltage triangle again. In this voltage triangle, divide everything by I. So what you will get over here is Z, R, and here you will get XL minus XC. So your impedance triangle will be this. Okay? I've just removed I from every side. So draw the impedance triangle. So you need to divide each of the voltage phasor by I. In the voltage triangle, we get impedance triangle. You need to write it down. I've already drawn it because it takes a lot of time and I want to cover more topics. So please note it down. Impedance triangle. From impedance triangle, by Pythagoras theorem, what can you write? What can you write? Z square is equal to R square plus XL minus XC the whole square. Is this correct? That is what Pythagoras theorem says, right? So write that thing. From impedance triangle, Z square is R square plus XL minus XC the whole square. So Z will be square root of, that. And Z value is ohms. Remember again, this impedance triangle is valid for XL greater than XC. Can you express this impedance in polar and rectangular form? Yes, you can. So if the circuit is inductive, what it will come? R plus XL minus XC. If it is capacitive, it will be minus. So please write down impedance in polar and rectangular form. Z is R plus J XL minus XC, and polar form will be, actually I should have written as Z bar. It will be Z angle phi in polar form. And what is Z? Z will be given by this formula. And what will be phi? Tan inverse of XL minus XC upon R. That's only tan inverse of XL minus XC upon R, which we calculated earlier. So please express Z, impedance Z in polar and rectangular form. How will you calculate power triangle now? What does the power triangle give you information? Power triangle gives you information about the power factor phi. It gives you information about the true power, apparent power, and reactive power, meaning P, Q, and S. So for XL greater than XC, this will be the power triangle. Please draw it. For XL greater than XC, this will be the power triangle. And what are the formulas? Power P will be VI cos phi, Q will be VI sin phi, and S will be V into I. What are the alternative formulas? We have written this before. I'm just repeating it. Power is I square into R, Q is I square into XL, and S is I square into Z. Provided XL is greater than XC. And from the power triangle by Pythagoras theorem, S square is equal to P square plus Q square. I guess we have repeated the same thing in RL series and RC series circuit, right? Okay. So over here, we end our discussion for the first case. XL greater than XC. Now the second case, you don't write anything. You leave 2 pages, blank pages, and you complete at home. It will be just repetitive. Only draw the phasor diagram. Okay. Completed this much? Okay. Second case, XL greater than XC greater than XL. So obviously the circuit will behave like a RC series circuit now, where VC will be greater than VL over here. Okay. Now how will you draw the phasor diagram? Tell me. Now only phasor diagram you should understand properly. If you have understood it properly, you will understand the phasor diagram. Okay. So I'll take current as a reference. This is current. In which direction I'll show VC? In the RC circuit, current leads the voltage, right? Current is leading the voltage VC, right? This is VC. Where will be VL? Show me where will be VL? Current lags the voltage, VL. And why VL is less than VC? Because that is the case we are discussing. Now, tell me where will be VR? VR will be here, only here. This is VR. Okay? Fine. And why the phasor will come down? So this will be I. This will be your phi. And this will be your V, I into Z. This is VR, I into R. And this part will be what? VC minus VL. Are you getting it? Okay. Why it is inclined downwards? Because VC component is greater than VL. Please draw this phasor diagram. This is the same thing we have drawn, only draw the phasor diagram. Okay? You understood why VL will come up and VC will come down? You should remember current lags behind the voltage in a inductive circuit, and in a capacitive circuit it leads the voltage. Got it? And why it is coming down, the V? Because VC is greater than VL. And we want the difference VC minus VL now. So first you draw the current reference, then you draw VR, then you draw VL and VC, and finally you draw V, which will be I into Z. Now from the phasor diagram you get the voltage triangle. Got it? Same thing only. No need to draw anything now, just listen. Just pay attention and written, no need to write anything, you can later on complete it. It's similar. Why it is coming down, you have understood? Because in this case, the nature of the circuit will be capacitive. So the phasor diagram will look like that. So V is equal to I into Z, VR is equal to I into R, and VC minus VL is I into XC minus XL. So this will be the voltage triangle. Now from this phasor diagram, what can you say about the total current and total voltage? Current is lagging behind or leading the voltage? Current is leading the voltage by phi, where phi is less than 90 degree. So your circuit is, nature of the circuit is capacitor. Correct now? Current is leading the voltage by phi, not 90 degree, by phi, where phi is less than 90 degree. So the nature of the circuit is capacitive. What is the phase angle of the circuit? What will be tan phi? What will be phi? Tan phi क्या रहेगा इसमें? Tan phi will be VC minus VL upon VR. Got it? So if you simplify it further, you will get this. Phi will be tan inverse of XC minus XL upon R. Okay? Because not every time we have the value of VC and VL, but we might have the value of XC and XL. Okay? What will be cos phi over here? VR upon V from the diagram. So cos phi will be VR upon not V, VR upon V. Okay, so VR upon V, and it is R by Z, and this time it is leading. Remember in last case we have written lagging, right? So it is exactly on the similar lines we are dealing with the case XC greater than XL. All these things you should know. Impedance. What will be the impedance diagram? Voltage diagram. Divide each voltage phasor by I. So what will you get? Impedance diagram. Remember it's coming down. Don't confuse between the two cases. So this is the impedance diagram for XC greater than XL. Okay, all these things which I am telling you, you need to write it down in your books. Until you write it down, it won't register in your mind. So please complete it at home. Again, what will be Z square? This time Z square will be R square plus XC minus XL the whole square. Are you getting it? Why? Because we have considered XC greater than XL. Fine. So again, we represent circuit impedance Z in the polar and rectangular form. See, again, see carefully. When will negative sign come over here? Whenever there is a nature of the circuit is capacitive. So Z bar will be R minus J XC minus XL in the rectangular form. And Z bar in polar form will be Z angle Y minus phi. Y minus phi. Below, down, that's why negative. So This will be the power triangle. P, Q, and S. Down, again down. So again here simple, all the formulas remain the same, intact. Only thing is the orientation of the triangle is downward. So this is my power triangle for XC greater than XL. So accordingly the formula for P, Q, and S won't change. It is same, exactly the same. Only what is different? Instead of Q writing it as I square XL, here it will be I square XC. Got it? Understood this? So with this, we have completed the analysis for series RLC circuit only. Remember, you have parallel RC, parallel RL, and parallel RLC still remaining. And then you complete module number 2.3. So you have a lot of work to do. Now, I'll show you some techniques how to solve numericals on this. Okay? So here you need to write it down. Write down analysis of AC series circuit. Only write down the heading. I'll tell you what to write down next. So if it is any AC series circuit, whether it is RL, RC or RLC, and you have been applied a AC voltage V of frequency Hertz and AC current I. So how will you analyze such a network? So first of all, you need to express your circuit impedance Z into its rectangular and polar form. Okay? So Z bar will be R plus minus JX. Why plus minus? When it will be plus, when it is a inductive circuit. When it will be minus, when it will be a capacitive circuit. And what will be X? In case of RL circuit, it will be XL. In case of capacitive circuit, it will be XC. In case of RLC series circuit, it depends upon XC greater than XL. So we need to express Z in the rectangular form. What is R? Total resistance of the circuit. What is X? Net reactance of the circuit. Okay. So you first express Z in the rectangular form. R plus J plus or minus JX. Have you written it? Next, if the circuit is inductive, just listen now. If the circuit is inductive, that is XL greater than XC, imaginary part of the impedance will be positive. That means in case of RLC series circuit, if XL is greater than XC, there will be a plus sign over here. Okay, that's what you have written. And if the circuit is capacitive, XC greater than XL, then the imaginary part impedance will be negative. That means if XC is greater than XL, it will be R minus J, XC minus XL. Many are not paying attention. You will land up in trouble while this concept is asked in the form of a numerical. So kindly pay attention. Now, listen carefully. For any unknown AC circuit, let's say from the question itself, you cannot determine whether it's a series RLC. You're not able to determine that. So, if the rectangular form of Z is impedance is given to you, let's say in the AC series circuit, only this much is given. This much. Z is 20 minus J 30 ohms. Now tell me which kind of series circuit it is. So from Z, you should determine whether the circuit is capacitive or inductive. Now, how will you find that? If the effective component of the circuit is, that means real part of Z. Wait, yeah, I've already discussed this. 20, what is 20? It is R. What is 30? Well, depend upon XL or XR. Whenever there is a minus sign, that means it is a capacitive. So 30 is XC. Are you getting it? If it was 20 plus J30, then the circuit would have been inductive and 30 would have been XL. That is what this is explaining that. Okay, यही समझा रहे हैं. If imaginary part is positive, circuit is inductive. If it is negative, it is capacitive. And the phase angle of the circuit will be imaginary part of Z bar divided by real part. Okay, phi will be tan inverse of imaginary part divided by real part. Just now we considered an example, right? Just now we have studied what is phi given by tan inverse of, in case of XL greater than XC, XL minus XC upon, uh, what was it, R, right? And how we represent Z? R plus J XL minus XC. So isn't this the generalized form valid over here? The imaginary part is XL minus XC and the real part is X. So imaginary part of Z bar upon a real part of Z bar. Got this? This I am saying generalized. It is also valid for series RC circuit and series RL circuit. So take this example, note down this example. This will help you out. Note it down. Even if you know it, still note it down. Z bar is 20 minus J 30J. So R will be directly 20 ohm. You should be able to identify it. X will be 30. Nature of the circuit is capacitive. How? Because imaginary part is negative. And phi will be tan inverse of imaginary part upon real part. So this much information you should already have in your hands just by looking Z. Okay? Please note it down. Fine. Now, where negative sign? This minus. What? No, we don't take the negative sign into the formula. We have seen that the analysis so far. We have not taken negative sign. Only angle is negative. Impedance, resistance कभी negative नहीं होता. It's always positive. It's even if it is feeling like it's negative, what happens is current and voltage are leading or lagging behind each other. That is only happening. But resistances are purely positive only. Okay. Now, again, if the same, now don't write anything. If Z is given in the polar form, how will you identify whether it's capacitive or inductive? Now tell me. Tell me this. How will you do that? If it is in the polar form, Z is 10 angle 45 degrees. So what is magnitude of Z? What is the standard form of Z over here? Z bar is Z angle phi. Okay. So you can calculate Z from here. Let me show you directly. Z will be 10 ohms. What will be phi? 45 degrees. Okay. Nature of the circuit is inductive because the angle is positive. If the angle is negative, it is capacitive circuit. These are small clues which you should know. Fine. Now last thing, by Ohm's law we can calculate the unknown quantities. Ohm's law is very important still. So circuit impedance Z will be V upon I. This you already know. Or Z bar in vector algebra we can find it as Z bar is V bar upon I bar. Division of polar coordinates in polar coordinates. Circuit current will be V by Z. These things may look silly now, but this will really help when you're solving a numerical. So I bar will be V bar upon Z bar. When you can divide two vectors in this case, whenever they are in polar form. Okay? And the voltage across the circuit, total voltage is I into Z. Again, we can multiply them in the polar form. So these are all the clues which you should know while solving any numerical. Is this fine, everyone? Yeah, you have any doubt or any questions? Ask. Any doubts further? So Even if the information in the numerical is given in the form of Z, you should be able to decode it very quickly. Now let's solve a numerical and numerical number 1. For the circuit shown below, find A, circuit impedance, B, circuit current, C, power factor, D, active power, E, reactive power, and F, apparent power. So all the three types of power you require. Let me draw the circuit. So it's a RLC series circuit. Okay. The value over here is 200 volt, comma 50 hertz. This is C, L, and R. The value of the resistor is, write it down, 20 ohms. L is 0.1 Henry and C is 50 microfarad. So obviously there will be a AC current flowing in the circuit. I'm marking it as capital I. Okay. Obviously we don't have that much time to solve this. I'll only discuss the thinking process and we will solve it tomorrow. No problem with that. Okay. So actually we have continued lecture number 20 most of the part and we have just started with lecture number 21. That's fine. So this is the thinking process. So what is supposed to be found out? We are supposed to find out circuit impedance Z, current I, power factor. What is the active power given by P, reactive power Q, and apparent power S. So what is the thinking process? RLC circuit is given to you. Okay. So find the circuit nature. How will you find the circuit nature? You first find XL. What is XL given by? 2 pi FL. And you find XC. What is XC given by? 1 upon 2 pi F into C. And then you determine if XC is greater than XL, then the nature of the circuit is inductive. If if XC is greater than XL, in first case, if XL is greater than XC, it is inductive. If XC is greater than XL, it is capacitive. Okay. So from here, you will determine whether the circuit is inductive or capacitive. The next step is express Z in polar form. Okay. So now you can calculate I, which is V by Z. All right. Then fourth will be calculate power factor, which is cos phi. Fifth will be calculate P, which is VI cos phi. Then calculate Q, which is VI sin phi. And calculate S, which is V into I. This is the strategy. All right. This is a thinking process. This is what we will do. Before even solving a numerical, we have thought about this technique. And whatever I made you write before, the analysis of any AC series circuit, you should do it this way first. Don't directly start jumping first. Think and observe what you think you can calculate on your own. All right. I'm not pushing the time further. So I'll stop it over here and we'll solve this numerical of rest tomorrow. At least series part will be completed by tomorrow.